A very good morning, good afternoon and good evening to all my friends, participants and candidates for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you are aware, the three main topics which are being covered in this 60 lecture, which is 30 hours course, and for each week, as you are aware, there are 5 lectures, each for half an hour. The topics, as I was saying, the three main topics are: number 1 is averaging and forecasting technique, number 2 is regression models. Even though it is written as multiple linear regression, it is regression models, because I will discuss few other type of models also, which I will come in due course of time, and the last topic being time series analysis. So, we are in the midst and almost at the fag end of discussing averaging techniques and forecasting models. This is 5th week, 23rd lecture, which is we will try to wrap up the concept of forecasting by this end of this week, which means we will be left with another 7 weeks, and in that we will definitely try to cover in all details, as we did for forecasting. The concepts we will cover in the coming 7 weeks would be in the area of regression models and time series. Now, when I did mention that we will definitely wrap up forecasting, so hopefully with few examples that will complete the whole loop, and I am sure all the models, everything with the examples would definitely be covered in this 5 weeks for the forecasting concept. So, what is the coverage for this 23rd lecture? We will consider the Holt Winter method, the multiplicative model. So, if you remember in the last 2 lectures, which is in the 21st and 22nd, if I remember correctly, we were considering in the slides as well as considering the Excel sheet, the idea of Holt Winter method, where it was the additive model. And if you remember, in the Holt Winter method, both for additive and multiplicative, the main difference with respect to the Holt linear method is that you have a seasonality concept. In the case of Holt linear method, it was basically the level denoted by L with the corresponding suffix. There was a trend which was given by B with the corresponding suffix, and in this case of Holt Winter method, you have the seasonality which is given by capital S. Now, again I am repeating few things which we will double check, triple check as we proceed and do the problems. So, the parameters which we had considered in the earlier models, not the Holt Winter additive one, it was basically alpha and beta, and both the parameters were between 0 and 1. Now, if you remember, if you can recollect that in the Holt Winter additive model, we consider 3 parameters: alpha, beta, gamma. So, same concept will continue in the multiplicative model also. Now, what are the important parts? They are exactly, almost exactly the same. There will be some intuitive difference between them. And if you remember, I did mention when we had just started Holt Winter method for the seasonality concept, the idea would be basically in one case the seasonality effect is being added, and in the other case the seasonality effect being multiplied. Now, I did also mention the seasonality concept being for 4 months. That means, we have the concept of seasons as summer, winter, spring and autumn. But in one of the problem, if time permits, which I will try to do in most probably in your 25th lecture, would be where you consider the seasonality in such a way that it has got, does not have 4 months, it will basically be repeated after 12 months. And what is that? I will come to that when we use a live data set, actual data set. Now, again I am mentioning, do not confuse seasonality with the cyclicity. There is a cycle. Cycle can be for weeks, can be for months, can be for years, can be for decades. So, the main focus for Holt Winter, both additive and multiplicative, is the concept of seasonality. So, what are the main parameters and the variables which are there for this Holt Winter multiplicative model? They are exactly the same, but I will still repeat. So, the continuity of the discussion continues for this course. So, I will mark them correspondingly with the violet color. So, you have the level which is given by L, and obviously with the corresponding suffix T, and if you remember, you have alpha as the parameter for the case when you are trying to find out the level. Now, remember one thing, if you pay attention to this formula which I will highlight using the orange part, this you see there is a division, but that concept was not there, division concept was not there, that was basically the concept of addition and subtraction. So, that was basically subtraction there. Now, you have the second component on to the right hand side of the equality side is basically 1 minus alpha, because alpha is the weight, and you have basically the past level and the past trend. So, that is the part corresponding to the level. So, you have basically the level which I will mark in violet. This is the second part, two parts which are there, and depending on the weight which you put for alpha, you can give corresponding more weightage, less weightages to this concept of the term which is yt by st minus s, and the other concept being lt minus 1 plus bt minus 1. Now, remember here, the suffix which you have is t is the time frame where you are standing, that is point 1. The number 2 point is basically there would be an m, and m is basically how long forward you are trying to basically forecast. And if you remember, we have taken the concept of m as 1, that means 1 period at a time. The other concept is basically the idea of small s, that would basically give us the idea or the notion or the concept of the seasonality in the time concept. So, if m is 1, seasonality for the case when you have 4 seasons a year, the small s will be 4. In many of the cases, if the seasonality is repeated or the concept of seasonality is being assumed in the model for a 6-month time period, then small s would be basically be 6. If it is for 1 year, then small s will be 12. So, small s is always the time concept based on the seasonality. The second one parameter or the value which I have, I will use the green color, is basically the trend. So, level is basically again coming on the first one, level from where you are starting, trend is basically the average. So, which is given by b suffix t, t being the time frame, again I am repeating, and that would be given by the difference of the level of LT minus 1, which is being weighted by that the parameter beta. Beta is the second weight. The second term is basically which you see, where I am just putting the green tick mark. The first one was beta into LT minus 1. When I talk about T, small s and m, they are all in the suffix, but when I am talking about capital L, which is level, trend, which is small b, only that small letter is used. The seasonal concept based on the value would be capital S. So, coming back to the trend, the second term is basically 1 minus beta into bt minus 1, which is basically the trend one time period in the past. The third concept is basically I will use the red color, is the seasonal concept, which is given by s suffix t, and it is basically the parameter is gamma multiplied by yt by lt. Yt is the actual value as you know, and lt is basically the level at that time. And again the second term is 1 minus gamma into st minus s, s suffix t minus s, that means how many such time frames you have to basically go back. Having calculated capital L suffix t, small b suffix t, capital S suffix t, we are now ready to find out the forecast. So, the forecast would be given by how many time periods you are going. So, if m is 1, it will be, let me use a different color, so light blue. So, here if m is 1, so you will have basically f t plus 1, where m is 1, that will be given by L t, that means the level of one period before considering m is 1, into B t into m, m is obviously 1 again. I am repeating few things time and again. So, please bear with me, and that whole thing being multiplied by s suffix t minus s plus 1. So, that means you have gone back t minus 1, then you just take one step forward because m is 1 and then proceed. Having said that, your values of Si would be given by yi by Ls, and remember yi basically is from y1 to ys, depending, ys means small s, depending on number of such seasonality concept of time frame which you have. So, here one considers seasonality is multiplicative in its characteristics. The level equation for Holt Winter method differs from the level equation on Holt method or Holt general linear method, as we divide here with S t minus s, which is done to de-seasonalize the concept which has come on to y t. Y t, that means we remove the concept of de-seasonality and then calculate. Now, in the case of Holt linear method, this concept of seasonality was not there. So, seasonality concept is there only in the additive and the multiplicative model. So, this is the same nomenclature we are following, the same way how the slides have been put, such that there is a logical flow in the discussion. So, y t, as you can see in the slide, is actual value, f t plus m is the forecasted value, m time periods forward, L t is the level of the series and does not consider seasonality. L is basically the level from where you are, a snapshot. So, at which position. B t is the trend, which is per unit time change. Capital S suffix t is the seasonal component, small s is the length of seasonality, m is the time period, which is how many periods ahead you are trying to forecast. Alpha, beta, gamma are the corresponding weights for level, trend and seasonality, and alpha, beta, gamma are chosen in such a way that you would basically try to minimize the metric, which can be mean squared error, it can be mean absolute error, it can be weighted mean square error, it can be weighted mean absolute error, it can be percentage error, it can be weighted percentage error, U statistics, whatever. I keep repeating this matrix because we have already tackled all these things using the formula in all the slides what we have covered till now. Now, here is the data, same exact data, we are trying to utilize the concept of multiplicative model now, Holt Winter multiplicative model. In the first column, you have the year. In the second column, you have the quarter, because it is being divided into quarters. So, they would be 1, 2, 3, 4 quarters. So, 4 into 3 is 12. So, it is being repeated. Then the third is basically the time period, we have just named them starting from 1, and the fourth column is basically the y value. So, fifth, sixth, seventh and eighth column are basically the repetition respectively of first column, second column, third column and fourth column, because fifth column is the year, sixth column is the quarter, seventh column is the period and eighth column is the actual value. So, actually you have basically 6 years of data. If I consider the quarter, it is 6 into 4, 24 data points. Now, these are the assumption of the starting values. Now, starting values, if you remember, for the additive model, we consider different concepts of starting values and the graphs were illustrated. We will do exactly the same thing for the multiplicative model also. So, these starting values are chosen as you see in the slide, but obviously depending on the Excel sheet, the values which you change, you will definitely have different sets of graphs corresponding to different sets of values for alpha, beta, gamma. So, alpha is taken here as 0.95, beta is equal to 0.4, gamma is considered as 1, S is 4 months and already mentioned. To initialize the Holt Winter forecasting method, we need initial values for LT, for trend BT and the seasonal indices capital S suffix T. To determine the initial estimate of the seasonal indices, we need to use at least one complete season data, which is S period, small s period. We did exactly the same thing in the additive model. So, with this I will switch to the Excel sheet in order to solve the problem. So, the Excel sheet when I end the this forecasting concept, I will mention that what are the different sheets which are there in the Excel sheet, and where you can find the corresponding data. So, they would technically be in that Excel sheet, there will be two sheets. One is basically not directly related to the course which is being taught here, but it would be helpful for many of the people who want to at least understand different type of distributions which are being used or which are used for different studies. This is just a set of information, the sheet 1 which you will have, which I will come to within few minutes, which will help you to understand how the different distribution looks like. In sheet number 2, in the same Excel sheet, all the problems which we have discussed in the PPT slides are solved there, and you can change the problems and do the calculations accordingly. So, if you remember, I did mention that you can definitely solve the problems much faster, considering that if you write the adequate codes in either in R, in Python, in MATLAB, in SAS, in Statistica, whatever it is. But I thought I will just stick to using the Excel sheet, because it will be much easier for us to explain, and many of you would be using Excel sheet to solve the problems. That is point 1. And point number 2, using Excel sheet is much easier to communicate, because yes, trying to basically build up the models using different type of coding or software is useful, but if you do hands on starting from scratch using the thumb rule 1, where you understand each and every step, then it will be much easier for you, number 1, to understand how the problem is solved, and number 2, to build up a much more sophisticated models accordingly. So, I will basically come back to another one slide which is required, which we will be referring to time and again. This is the slide. The slide is basically the starting values, how you calculate. So, you find out L suffix S as y1 to ys, sum them up, average of all the values in the seasonal time frame. You have Bs, which is basically given by ys plus 1 minus y1, the first difference divided by s, and you continue till ys plus s, which is y2s minus ys divided by s, and all these things you find out the average. S1 to SS, that means how many such seasons you have, the seasonal concept, you will basically find out y1 divided by ls. Ls you have already calculated, and we have done that in details when we are doing the additive model. So, I will now come to the Excel sheet. Once I finish this multiplicative model, then I will discuss what are the components in the Excel sheet. So, I am utilizing the sheet in the Excel file, the sheet which has basically forecasting, if you see here where the cursor is, and there is another sheet which basically has distributions. I will come to that later on. So, first let us consider the Holt Winter method, the multiplicative model. So, the data has all been copied. So, basically it is given from year 1, if you see, till year 6. I have just done it all vertically. Then the quarters are given 1, 2, 3, 4, 1, 2, 3, 4, and if you consider the seasonality concept, would consider where small s is 4. Period is given, that means you have basically marked them for simplicity, or if you want to mark which period it is, because you are going in the sequential manner from time period 1 till time period 24. So, they have been marked 1 to 24, if you see it here, and the data set is basically given in YT under YT column, which is basically the column J here. Now, what are the values which we start with? Number 1, the small s is 4, as already discussed. Alpha values we can change. So, if you see the Excel sheet which I just the PPT slide which I just discussed, the values of alpha and beta were taken something else, we will basically keep changing that. So, the changed values are being illustrated here. Alpha is given here, beta is given in these two cells. So, the top part is what the value you are taking, and this is 0.07 for beta, gamma is considered as 0, here m is as equal to 1. Now come back to L. If you go back to this slide, which is the PPT slide, it says that LS is equal to average of Y1 to YS. So, you have to consider one cycle of seasonality here. So, what it is? Let me highlight. So, basically this should be, if you remember, Y1 plus Y2 plus Y3 plus Y4. So, if I consider Y1 plus Y2 plus Y3 plus Y4 divided by, so this would be the seasonality concept. So, it will be divided by S. So, I can keep changing S. So, S is 6. So, it will change accordingly, but you have to take 6 such values. So, this value comes out to be 380, and this 380, if you remember, would be copied for the cell K278. So, I will mark it also in red. So, there is no ambiguity in the discussion which you are doing. We will mark it with the arrow. So, you know where it is going. So, this is basically LSL4. Now, coming back to B4. So, what we do is that if you go back to this formula, you find out the concepts accordingly. So, you have the ratio which you are considering, the difference ys plus 1 minus y1, ys plus 2 minus y2. So, I will go and utilize this formula which is already given here, but for simplicity I have just, so it is basically given by the value of y5 minus y1. So, it will be y5. So, y5 is basically this minus this divided by 4, 4 is from S, plus again y6 minus y2 divided by S, which is 4, plus y7 minus y3 divided by S, which is 4. Finally, the last term is y8 minus y4 divided by, this value is G272, and this whole thing you basically put in brackets and then divide by 4. So, if I consider the terms, so you have 4 terms. The first one is y5 minus y1 divided by 4. The second term is y6 minus y2 divided by 4. 4 is basically S, the smallest value. The next value is y7 minus y3 divided by 4, and the last value is y8 minus y4 divided by 4. That value comes out to be 9.75, which you have already seen, and 9.75 is calculated here. So, we basically put it as required. Sorry, just this should be made green, bold, green means the dark green, done, and the arrow should be pointing in order to illustrate. We are bringing it here, done. Now, the values of S1, S2, S3, S4, which are marked in the yellow, pink, light blue and dark brown. So, this is 0.95 is actually the value which you have. So, I can maybe this would be copied from here. So, it is better to put here, and this should be copied from here. Perfect. Now, this 0.95 would basically be the S1 value. S1 value you know is y1 by y1 divided by L4. L4 is basically 380. So, this is 0.95. 0.95 basically goes to this cell which is marked. I should mark with the yellow color as given. So, it should be bold. So, the arrow comes here. Next is the pink one. So, that is equal to y2 minus y2 is 385 divided by L4. So, that comes out to 1.01. They should be marked in pink and a bold. So, this is done. The third value is light blue y3 by L4. So, this is y3 is 432 divided by 380, which is L4, that comes to be 1.14. So, 1.14 value should come here. So, done. I will basically mark it as light blue. Yes, yes, and that should be done. And the last one is dark brown. So, this value is y4, last value is 341 divided by 380, that comes to be 0.90, which is as already noted down. So, I will copy the value here, mark with the dark brown or dark red color it is, if I am not mistaken. It is dark red, sorry, not brown. So, the values have been calculated and put in their right perspective places as marked by these arrows. We had done the same thing when we are doing the additive model. So, once this is done, so L4 has been calculated, B4 has been calculated, S1 to S4 has been calculated as given. L4 calculated, B4 calculated, S1 to S4 has been calculated and plugged in the Excel sheet. Now, I go to the formula. So, the first one is basically the level. So, you have to find out level, the trend, the season factor and the concept of forecast. So, the fifth point, which is basically S1 to S4, has already been done. The fifth factor LS has already been done. So, we need 1, 2, 3, 4 to solve. So, I will just take the time here. So, a level is given, L have to find out. Level will be equal to alpha into yt by st minus s. So, alpha is here multiplied by its corresponding value of yt. Yt value is given in J column 240 is 279 plus 1 minus alpha. I have to fix alpha, which I will do later, multiplied by this is LT minus 1 value back, which is J 278 minus the value of wait, or it will be divide should be divided, sorry, yt by, so this would be, this terms won't come. I will again recalculate. So, basically alpha multiplied by yt, yt is given by J279, J279 divided by the value which is st minus s. So, the seasonality component would be t minus 4. So, basically if I am trying to find for the fifth time period, I will go fourth step backwards. So, fourth step backwards would be basically given by S1. So, this is done plus 1 minus alpha multiplied by the factor is LT minus 1 which is one time period back, which would be K278 plus BT plus 1, which is BT minus 1. So, BT minus 1 is 9.75. The value comes out to be this. So, this is 397.62. Now, when I want to find out the trend BT, I found out the value of LT. I need to find out BT. BT is equal to beta multiplied by, in the bracket you have LT minus 1. So, LT minus LT minus 1, which is the difference between J279 minus J278 plus 1 minus beta into value of BT minus 1. BT minus 1 basically was the value of 0.9 BT minus 1 would be this. So, you have the value of BT. Finally, seasonal factor would be gamma. I am taking few minutes more for this, please wait. So, it is ST is equal to gamma, where yes. So, this would be value of gamma multiplied by YT by LT would be YT divided by LT for the same time period, if you remember, plus 1 minus gamma into ST minus 1. ST minus 1 would basically be the value of S1. So, this is the value of the S value which I find out. Forecast would be equal to LT is equal to LT. LT value I already have is this, plus BT. BT is for the same value of, which is M279 into M is 1. This is into S T minus S plus 1. So, I will basically move 1 forward, which is S2, and the error would be given by difference of YT minus the forecasted value, which is. So, I will double check, but these formulas, and in the meantime I will take a break and end this session, and before I start the 24th session class, I will double check the formula. So, if there is an error, I will mark it out, considering I have copied the values accordingly. Thank you very much for your attention, and I will try to basically go slow for this multiplicative model and wrap up at, as I promised, by the 25th class, which is the 5th week, all the concepts in forecasting model. Thank you very much, and have a nice day.